good software. What do I mean by that? The problem is that smart people can keep so much stuff in their head that they can sit down and they can start making progress. They can keep it all bouncing around. They know what they're doing. They can make progress without having any kind of proper process in place. All of us do this, right? We sit down and hack. We've got something we want to build and we just start typing. We bang it out and it's really, really cool. This is not a good thing when you're trying to deliver high quality software or build large things with a team that have a multi-year lifespan that you're going to have to maintain. So really your intelligence is working against you when you are trying to do real proper projects. Let's look at a couple of examples here. I want you to read and process this. Right? What do you think about that? If your doctor said that, how would you feel? Probably not so good. How about these engineers? Right? So
I don't contact her like that.
So obviously we all laugh at these. These are patently ridiculous, right? So the question is, why is a lot of people's attitude about building software like this? What is distinctive about what makes these two slides funny? It's because we know implicitly that professionals design, plan, and prepare their work first. They don't just dive in, they make a plan for what they're doing. And what's important about that is not just that it produces better results, but that it produces better results faster. Because when you have a plan, you know what you're doing and you're not just flailing around making guesses and wasting time fixing the mistakes you make when you are working against guesses. So process, not intelligence, is the difference between surgery and cutting people open. It's the difference between engineering and tinkering. And it's the difference between software engineering and programming. And what I've seen out there being a working developer is that a lot of people don't realize that these are different things. It took me 20 years to get it. I'm a self-taught programmer. I don't have a CS background. I was an engineer in college. I started programming on a Commodore 64 in my parents' basement many, many years ago. I'm going to date myself a little bit there. And I learned probably, at this point, I've probably learned 20, 25 programming languages. And so I was a programmer. Great, I'm going to dive out, do freelancing, and build web applications for people. And I built a lot of crap. I mean, just absolute garbage that I cry when I think about it right now. And what's happened in the last few years for me is I have learned the difference between these two things. I've learned what it means to have a proper process and get software built the correct way. So, here's our equivalent slide. I hear this a lot at my clients. Don't be this guy. Don't be this guy either.
Be his dad.
Yeah, exactly. By the time you've done this, you've already lost most of the advantage of writing tests. So let's talk about what tests give us. So a lot of things go into software process other than the ability to program. We have to know how to architect our programs right. We have to follow conventions and standards. These are important for communicating between other developers, keeping our group coherent. We use version control. That's not fundamentally part of programming, but it's an important part of the process to keep our code in good quality. We use various coordination techniques that are being developed. People are working on them all the time. And finally, I'm sure there's others, but finally, test-driven development. This is a really critical part of the modern software process. So, there's a big difference between tests and test-driven development. Okay, so what do tests give us? We document our code by writing our tests. That's a good thing. Better than 20 years ago where we would have just written comments and nothing else. Tests are at least, they're a more valid living form of documentation of our code. Obviously, they help us catch future errors, right? If I test my code now, then when my teammate breaks it, we know, and we save a lot of time rather than deploying broken stuff. We get long-term time savings because we catch errors before we deploy broken stuff to our production server. These are all useful, but this is just a tool. Tests themselves are not a process. The process of doing tests properly has a whole lot more advantages than these. So, let's talk about what we mean by test-driven development. In its simplest form, it basically comes down to First, we decide what the code we're going to do is going to do. Then we write a test that will pass when the code does its thing. We run the test first to prove that the code fails, or prove that the test fails. Then and only then do we write the code, and then we run the test again to see it pass. Lather, rinse, repeat. Do this for every couple of lines of your code, every method, everything that you're building. And what does this get for us? Yeah.
I'd like to point out, if you go back, that step of running the test and seeing it fail is more important than you would think.
Yes.
A lot of times you can write a test, I've done it myself, that will never fail. Go in, write your code, see it pass, and you're happy, right? Always see the test fail.
Right. A common one I've done probably a dozen times before I started doing this as gospel. I'm writing a Rails application, I've got a controller thing. When I do this, I write the code, and then when I send this thing to the controller, params something in the hash should be blank. Okay, that's great, right? I want to prove that this doesn't get sent. Okay, but I misspell the key that I put in the params hash, which means it returns nil, which is blank. Doesn't matter what I sent to the code, I've just written a test that can't fail. So always write the test first, see that it fails. If you have to backtest, and there are situations where the code is there and you have to backtest, write the test, break the code, show that the test fails, re-enable the code, show that it passes. This, Alf is absolutely right. Making sure that the test can fail is incredibly important. All right, so what do we get from test-driven development? We are doing a design and a plan before we write our code. We are documenting our design before we build it. We are proving that our code implements that design, and we are encouraging design of testable code. And I highlighted this in blue because this is the most important bullet point here on, fourth bullet point of slide 15 is the most important thesis of my presentation. All of these things above are what's making us engineers as opposed to hackers, right? These are our blueprints. The aerospace engineer makes a blueprint of a plane before she builds the plane. Same with the civil engineer. The surgeon lays out a surgical plan before he cuts into the patient. That's what we're doing here. In software in particular, building that plan gives us better results. So testable code remarkably looks a lot like good code. When you write the code first, and I see this all the time in my clients' work, we pull up stuff that they haven't tested, and we've got methods that are 700 lines long with 5 or 6 or 500 or 600 if statements in them. And you go to write tests for it, and you can't because there's just too much crap in there. Sometimes you'll even see short methods, 4 lines long. Oh, it's a really simple method. You go to write tests for it, and you realize the test file is going to be 800 lines long to cover all the possible cases of all the conditions that are in there. That tells you that code is too complicated. If you write the test first, you can't write the code that's too complicated because you've made a declarative statement with the test. This is the thing and the one thing that this code will do. Now when you go back to write it, it's going to be a nice, short, simple method that does one thing and does it properly, is easy to understand and easy to maintain. So testable code is modular, forces us to break things down so that we can test them. Decoupled design, if our objects or our methods or anything else are too tightly interwoven, we can't test the two parts independently. So if we write the tests, we have to modularize our code. Our methods have limited scope. They're not trying to do too much in one place. And lots of other things. Why don't we open it up for a second? Anybody else want to toss out some examples? Alf? I know you're as much a proponent of tests as I am.
Those are the key things.
Okay, well, maybe we've got it then.
Your methods end up smaller. Your methods just shrink
Yeah.
in a good way.
And the type of shrinking I think that's more important than the size is shrinking in cyclomatic complexity. Does everybody know that term? Does anybody know that term?
Define all terms.
Right. So cyclomatic complexity is a measure of how many different paths there are through the code. Essentially, every conditional you add to your code gives you another route through the code and effectively gives you another test you have to write for that method. So if you have 20 if statements in your code, there's going to be, well, actually like 20 factorial different paths through the code. That means the cyclomatic complexity of your code is too high. There's a strict definition of, and I think it is exactly the number of conditionals or the number of conditionals plus 1, but I'm not 100% sure on that.
Something like that.
Something like that. So that actually matters more than length in terms of measuring how complicated your code is, but in any case, that's really what we want to
I
limit.
think the key thing that I always find is that it makes my code modular and in a good way.
Mm-hmm.
I'm writing my tests, I'm organizing my tests around particular types of functionality, and then I end up writing modules that match that functionality.
Right.
Whereas, like you said, you're never going to write a 700-line method that way, because your tests are going to be so ridiculously complicated in order to support a 700-line method that
Right.
you'll never do it.
And you can use that as a metric. As you're writing the test, if the test that you're trying to set up is too complicated, that's a code smell before you've even written the code. That says you're thinking about this in a way that is going to result in poorly designed software. Try and find another way that lets you break this into more elementary modular
Yeah.
sections.
I think it makes your code simple because you want to write a simple test so that you can get to writing the code.
Right.
The
Exactly.
other thing too, that red, green, refactor, right? Red, you wrote a test that doesn't pass. Green, you wrote some code that makes it pass. That's not when you go away. That's when you actually refactor it. Your tests should not require changes if you are refactoring.
Right. Absolutely. And I'm going to mention refactoring a little bit later on in another context. Okay, so the result, and this is what is hard to see, is that you actually end up coding faster. And I don't mean just the fact that our code is better means we save time in the long term. I mean, when you're sitting down and doing it properly, you will get it done faster now. Not weeks later, not time saved for the team. You will get the job done faster today. You will get that feature out the door sooner because your thinking was organized, and you'll spend less time flailing. It doesn't always feel that way because processes feel tedious. They do. They feel like extra work. But good processes are there because they make us better developers.
I have one caveat to that statement,
Mhm.
which is the first time you do this, it will take you a little bit longer.
Man, I love you, Al. It does take a while to learn this, to get good at it, and to really feel it. Okay, so the other caveat is intelligence isn't just a liability, it's also an asset. Because you can't do this in a vacuum. You have to be smart about how you test. There are a few places where you need to use your judgment. Some things are too hard to test. I ran into a place with a client lately, client we were doing some code rescue for, who's effectively a Pinterest clone. They were writing a feature to log in with your Facebook account and use that and the fact that Facebook can also authenticate with Pinterest to copy your whole Pinterest account into their application, right? Clone all your data, import everything. This was great. I thought about trying to set up the fixtures for an integration test of the entire thing, and I realized it was going to take me a day to automate creating a Pinterest account just so that we could do all of this. Facebook gives you tools, they're crappy and hard to use, but Pinterest doesn't. So sometimes you have to be aware that this thing might not be worth it, particularly external integrations with other tools that you don't have control over. It is possible to write tests that are too trivial to be useful. Over-testing is also possible. Try to test each thing once. If I've got a method in my model and I test it that it works, I don't have to then repeat that test in every controller that uses that model. I can test what the controller does in isolation. And there are cases where it's fine to code without testing, right? Sometimes you don't know what you want to do yet. Sometimes you don't know how to do it. You don't know what's possible in your language. You're just fooling around to see what you can do. I call that exploratory coding. It's fine to do that without tests. But as soon as it starts looking like it's going to be production code or you're going to use it, stop, back test, and then refactor. And for me, this is where refactor is the most important because exploratory code is usually garbage. So once you've written that thing, now you know what it does, immediately refactor it before you move on. Okay, so I want to go on, yeah, go ahead.
Just to riff on that for a second, Dan North, who is one of the creators of behavior-driven development, actually calls it spike and stabilize. So
Okay.
it's a practice that's been quite well accepted by even the guys who write the books. So
I believe that. Amen. Oh, and yeah, behavior-driven development from my point of view is an equivalent term. right? It's what people who write RSpec tests call it, as opposed to people who write test unit. I don't care which frameworks you use. There are holy wars about all the frameworks. I care that you have one, you get good at it, and you use it. I think they're all equivalent, and you can do the right kind of work in any of them.
I have two questions. The first one is do you have examples of, what's the example of the people who did the best? Like, is there a code in GitHub of the best example of just the right amount of test and
No,
opinion?
I don't off the top of my head know one that's exact, but actually, Alf, how much time do I have?
Sorry.
Okay, because I do have, I do want to walk you.
into it.
15 minutes.
I have 15 minutes left?
Yeah, you're 17 minutes in right now.
Oh, right on. Okay, so I have an example with me that I wanted to share with you all, because this was a case that I went through recently where I was writing a web application that I knew was going to be less than 10 lines of code. Right? It was a little gift for my girlfriend. It was going to be quick and easy. And so I was going to do this one without tests because it was so short I didn't need them. And this one, more than anything, is the one that taught me my lesson about what a big mistake that was.
Never tell your girlfriend that the app you're writing for her doesn't include tests like you normally do for other people.
Right, right. Yeah, that would be bad.
Hers has
So-
extra tests.
Hold on one second. Hold on one second.
What, Giles?
If you really want to learn how to get good at tests, and you're looking for like canonical examples, it's destroyallsoftware.com.
I'm in.
Yeah.
Yeah, that's a good resource.
It's like, what, $9 a month, and he is obsessed with testing. It is,
Plus he's got a great
It's
voice.
like a podcast?
it's
Yeah.
like, it's video podcasts, yeah. Yeah, it's a subscription.
Okay, so my girlfriend plays a lot of these word games. Text Twist, every word crossings, Words with Friends. She's obsessed with all of these. And particularly in the ones where you've got levels, where you have to get all the words before you go to the next level, she gets really frustrated when she's on level 14 and there's one word missing, and she doesn't want to go back to the baby words in level 1. So she'd rather cheat and solve that one word and keep playing with interesting words. So I wanted to create this little application with her where you can type in, oh yeah, so I know that I have 2 spaces, and then CT, and 2 more spaces, and I've got, a few letters like that. What words are going to fill that space? Which is an obvious, straightforward little, let's get rid of the apostrophe there. Right, so doctor is the one that fits with those. So it's an obvious, straightforward little task. Load up a dictionary, take these 2 patterns, permute the latter one into all combinations in the first one, search the dictionary for it, right? I mean, it almost couldn't be simpler. I'm going to do it on an airplane. I don't have internet. I should have this thing done in half an hour, right? I mean, easy. Right? I mean, Ruby gives us a method called permute, right? How hard can this be? All right, well, I was in for a lesson.
CS1 homework assignment.
Yeah, pretty much. Okay, so, wow, that's actually bigger than I need it. That's not helping. Maybe I'll turn off full screen, see if that helps. If we do better then. Okay, so about 45 minutes in, this is where I was. I had found, while I was sitting in the concourse at the airline, I had found a cool set of dictionaries somebody had made and open sourced for word games. And it was broken down by language, right? Here's all the common English words, and then here's British, and here's American, and here's Canadian, just the words that differ, and broken them out by complexity level. So if you go to level 20, you've got the words used in kids' word games, and 40 at common word games, and 60 games like Scrabble with a big dictionary, and 100 all the words nobody's ever even heard of that nobody ever uses, right? So you can dial them in. And I thought that was pretty cool, because then I might be able to put a slider on my application later so people could decide how big of a dictionary they wanted, or checkboxes where they could do British English or US English, depending on where they're playing. This is what the directory of those dictionaries looks like, right? So I thought that's pretty cool. So instead of just loading one file, I'm going to load this into a hash of hashes called dictionary, where I've got which language it's for and which size. Is this the size 10 or the size 80 or whatever? And then I can search through the particular subset. And for now, I'm just going to use constants. I'm going to use just American and just the ones up through 60, right? Can anybody tell what I've already done here? I've already changed the design from what I did when I introduced the project, right? I'm already planning for future things as I'm hacking away. Now I've got this nice big data structure of dictionary, which is a hash of hashes of words, and this little thing to read it in. And this worked. I loaded this up. But I'm already changing what I'm doing without a set design. I'm hacking, I'm tinkering. I'm not doing engineering anymore. So then, let's look down at the actual, this is a little Sinatra application. So in my solve request method here, I take out the two patterns, I add this little G sub so that you can use spaces or underscores, little options there. And then I had done this map of the permutation and insert them into where the underscores are. So permute the letters you've got and insert them in there. And this was 45 minutes and I was just printing out the possible permutations, not actually searching the dictionary. And then my little output here that shows you the results. So all that's left is 1 or 2 lines, right, to search my combination of dictionaries, given which subset of the dictionaries I want for those permutations. And an hour and a half later, I wasn't done. Because I could not, for the life of me, pull things out of this data structure to get the results that I wanted. I was, this subset of dictionaries with merge and these keys and using Ruby enumerable, and they were always nil. And then I tried running Ruby debug to see what was going on, and I couldn't get debug to work on the airplane because I was in Ruby 1.9 and I didn't have debug 1.9 on the end. And so then I'm trying to use P commands. You can see where I'm using a few of them in here, right? I'm trying to dump output from this, but it's a hash of hashes, and it's getting these huge streams of stuff all over my monitor. I'm scrolling back through, I'm like, you know what? This is crazy. I need to modularize that. I need to test it. And I wasted an hour and a half trying to get anything out of that hash. It's simple, I should have been able to, but I couldn't. So let's step through my version control history here. Oh wait, no, I've got the keys in here. Okay, so we're gonna do this the right way. The first thing we're gonna do, load them all, is we're gonna define 2 objects. One is called the library, and one is called a dictionary. Make sure I've got the current versions loaded. Okay, so a dictionary loads 1 file. I confirm that it has the right number of words. I confirm that it has the right language. So a dictionary is going to know how many words it has. It's going to know what language it has. It's going to know its complexity level. I'm going to be able to ask those easily, and that's all it is. It's 1 file represented as an object. So I write that. And the code for dictionary looks really, that's a later version. There we go. So it's really pretty simple. For the moment, I put a constant in there so I don't load the really complicated ones. And all it does is load the file, read the lines, save them, and initialize my 3 accessors, language, level, and words. Okay, straightforward, simple, but now I know that it works. I wrote the tests first, then I wrote the class. This simple little thing does exactly what I expect it to. I do the same thing for library, which is going to be my collection of dictionaries, and all it's going to do effectively is have an array of dictionaries. So I have a new library, and all I care about when I've instantiated the library is that it has a bunch of things and that each one is a dictionary. I don't really need to know anything else about it. I could be doing more thorough testing, but here I wanted to do enough to get this stupid little application working. Okay, so then we step forward and I start doing a little more TDD. One tiny little bit at a time. So, dictionary. Now I've added one method down here. It's got a method called include. It'll tell me whether or not that word's in the dictionary. Great, that's solved. This is going to be useful later. Dictionary itself now has a really straightforward method. All right, now we're going to be able to tell our library which languages we want. So in library, I've now got a method called selected dictionaries. I want that to be an array. I want them all to be dictionaries. And I want it to respond intelligently to the languages. So English is the language that that works for all English languages, and then there's the subsets, American, et cetera. So what I want is if I tell it that my language is American, then the dictionaries that it returns should include the English ones and the American ones, but not the British or Canadian ones. And likewise, if I send an array, I want American and Canadian ones, then I'm going to expect that it has those. So this is solving the problems that I was having when I was trying to access things out of a hash of hashes. I've said that I want it to work, and then when I go in and write it in my library class, it becomes, oh, this is still a newer version. There we go. becomes pretty straightforward. Languages is English plus whatever ones I've passed in. And then I can return that array. So long story short, I work through the entire application this way, one at a time. And pretty soon, I've refactored it all. Well, it's not refactored because it wasn't working before. But now I've built it and it's working. And now at the top of my application, all I have is this one line. Libraries is solve library new. Done. And then the thing that I spent an hour and a half trying to write before just becomes this. Take my permutations, which I already knew was working, and then I check if my library matches that word. This entire process took me 35 minutes. I had spent an hour and a half trying to get this working without the tests beforehand. And then I went back and started refactoring everything else, because now that I had that nice and modularized, I thought, well, that's cool. And so I worked through and I modularized the permuter, and I modularized the parameters handler, because I realized, I was doing that subbing in underscores for spaces. And then I realized in order to keep the performance working, I needed to make sure users didn't send in a pattern that had more than like 15 letters, because otherwise the permutation list was so long that it was destroying my machine. So I broke these things out and gave them their own functions, tested them all first, wrote them, and at the end, the entire application looked like, get the right one here, because I changed the name at that point. There we go. So now the whole thing is about half the length. I make a parameters handler, I make a permuter, I make the list of permutations, I see if the library matches the words. This is very readable, and the whole thing got collapsed to about 4 lines. Each of those things is in their own clean module. I know what they do. I mean, this is kind of a trivial example, right? We're all writing code that's a lot more complicated. But the point is, this little guy, at one point, I wasted an hour and a half flailing, because I'm smart and I can keep it all in my head. And I really was flailing and getting nowhere. And then I start this, and in less time than that, I have a much more functional application. At one point, I had a perfect little refactor of matches word, because matches word was pretty slow, right? It was just doing an array contains in Ruby, so it's searching the entire array. Conveniently, these dictionaries were alphabetized, so I could use a binary search, which I didn't even have to write because there was a gem that did binary search on array, assuming they were alphabetized. Plugged that in. All my tests still passed. It worked the first time, and it went from 30 seconds to handle a 10-letter pattern to half a second, or well, basically an immeasurable amount of time to handle that pattern. And because I had tests, I could plug in that different gem and throw in that technique and prove that everything still worked. So yeah, get used to it. Spend time learning this process, because it will make you faster. You will get your job done sooner, and you'll have better code to boot. And your clients will be happier.
In this case, your girlfriend.
And in this case, my girlfriend. Right, and of course the punchline is I launched this, I used a Heroku free and threw that out there for her, and the very first thing she did with it was cheat on me on Words with Friends. Very first thing. But oh well.
There's a moral to the story.
There is a moral to the story. Do I have a second left to make a little pitch?
Yeah.
Okay, so I want to make a pitch to any potential clients or employers or startups or developers out there. The marketplace for developers is really tight right now, as everybody knows. It's really hard to find good developers because there's 1,000 startups happening. Everybody who's building startups would rather have employees than bring in contractors. There's 1,000 reasons for that, and almost all of them are good. But a lot of people end up bringing in junior developers who are very bright but haven't quite figured all this out yet and really don't have good process down. There's nothing fundamentally wrong with that, but it often means that a lot of people end up bringing us in after 8 months to kind of clean things up, and there's a mountain of technical debt that they're sitting on at that point. I want everybody to learn this to help me make less money. I make a ton of money off those mountains of technical debt when we come in to clean up the messes that have been made. Bring us in sooner than that. Help us start off your project with good process, good version control, test-driven development, train your junior engineers. You'll get running much faster. You won't have to pay us for as long as if you wait 6 months until things are a mess. And in the end, you'll have better results. And we'll only have to work for you for 2 or 3 weeks, as opposed to the 4 months we might have to when we're coming in later. Because we have been doing mostly code rescue for the last 2 years, and we've seen a lot of stuff that I didn't want to see. It's why I felt this presentation needed to be made, because remarkable number of people out there are programmers but have not yet become software developers. So let's all try and become software developers and make the whole industry work a little cleaner and a little better. Thank you.